You are most welcome to another session. In this session, we shall be looking at parallel and perpendicular lines. We know that parallel lines are lines that do not meet. Parallel lines have the same gradient. For instance, if we have line given by the equation y equals to 2x minus 3 being parallel to another line, that means that they should have the same gradient. And we recently saw that the general equation is y equals to mx plus c. So our target is on m. Parallel lines have the same gradient. That's why we see a 2 there and a 2, meaning that they are having the same gradient 2. We come to perpendicular lines. Perpendicular lines are lines that meet at an angle of 90 degrees. And these lines have the product of their gradients as -1. For instance, assuming we have line L with gradient ML being perpendicular to line M with maybe gradient MM, that means that the product of this gradient and this is given by -1. For instance, if we multiply ML, which is the gradient of line L, times MM, which is the gradient of line M, we must get -1. This is the condition for perpendicular lines. Let us look at a few examples concerning parallel and perpendicular lines. We've already seen that parallel lines have the same gradient, whereas the product of gradients of perpendicular lines is -1. So, for instance, they could say, determine whether these are parallel lines. We have y equals to 3x plus 4. Then we also have y equals to maybe a half of x. Then we also have, we can have 2y equaling to x minus 1. Which of these three are parallel lines? Remember, parallel lines have the same gradient, and if you look at these three equations of lines, you note that the gradient of this is a half. The gradient of this is 3. What is the gradient of the last equation? We can, if we divide by 2, by 2, by 2, that gives us y equaling to a half x minus a half. Meaning that in these three equations, equation 2 and equation 3 are parallel because they are having the same gradients over half. Then, once again, for perpendicular lines, the product of the gradients is given by -1. For instance, we might be given one equation, for instance, y equals to 2x plus 3, and they ask for the equation of the line that passes through 1, -2 and is perpendicular to this. They want us to find the equation of the line that passes through 1, -2 and perpendicular to this line with this equation. What we do, we determine the gradient of this, which is 2. So we shall say m1 equals to 2. But what is m2? Assuming this is line 2. m2 is unknown. We have a condition that gives us m2. That condition is m1 times m2 equals to -1 if and only if they are perpendicular lines. So we shall use this condition to find the gradient m2. That is, now for m1, which is 2, it will be 2 times m2, giving us -1, whereby that gives us 2m2 equaling to -1. We divide by 2, giving us m2 as -1/2. That is the gradient of the second line that passes through 1, -2. Then to find the equation, we shall remember the general equation is y equals to mx plus c. So now we have got m, which is a -1/2. We shall use this point, which is 1, -2, to give us x and y. So that we have y, we have m, we have x. Now we can get c and then substitute to find the second equation.